Now the second example that I'm going to look at is this one here, the integral of dx over the square root of 8x minus x squared. Now having just come out of the section where we talked about inverse signs and all those kinds of things, we kind of should have some memory of, you know, there's stuff of the form x squared minus a squared and x squared plus a squared and a squared minus x squared, all those kinds of things as denominators. And if we look at, you know, the table that I started the last video by taking a picture of, basically, you know, we're looking for something that can give us this form inside a square root here. Now this is one where I look at this and I say, well, it doesn't look like that. It doesn't look like a squared minus x squared. But if I think about this separate from the integral, I'll just say, well, I've got 8x minus x squared. Or I could rewrite this, think in terms of minus, I could say, well, I have minus the quantity 8x squared minus 8x, right? Because if I was to distribute this minus sign, I have minus 8x, or minus x squared, and minus makes it plus 8x. So that's another way of writing what I have there. And when I look at that and I say, well, in order for this to make a square, because I want something where there's an entire quantity there squared, I'm trying to hit something that's going to look like this ultimately. So we can do the process called completing the square. I have that minus sign out there. I'm not worried about that right now. I have minus 8x, and then there's something that I need to add to that in order to make it a perfect square. The way to make a perfect square, you look at the x term, take half of it and square it. That would be 16. Of course, I can't just randomly introduce a 16 into the problem. But if I introduce a plus 16 and a minus 16, that's not a problem. So I'm trying to make this so that you can follow what I'm doing. I'm not doing the whole thing inside that integral. But now I'm going to say, okay, well then I can rewrite that like this, where I'm going to go ahead and distribute the minus sign only to one term here. Okay? That would be minus and minus 16, makes this a plus 16 out here. Now if I do that, in completing the square, I've done it here. That is x minus 4 quantity squared. So I rewrite that this way. And I'm also going to bring the 16 over here and write it as 4 squared. All of a sudden, this is starting to look like this form a squared minus u squared, where I'm now going to rewrite this to say this is dx over the square root of 4 squared minus x minus 4 squared. Okay? That's just because I started with what was under there and got right to here. Okay, so now I want to make this substitution where I say, well, it's of that form, so I'm going to say a is equal to 4, u is equal to x minus 4. Okay, u squared is equal to x minus 4 squared, so u is equal to x minus 4. And du is just equal to dx. It's an easy substitution to make. Du is dx, so there's du. Here I have square root of 4 squared minus u squared. And when I have that form right there, the formula that I took the picture of earlier on says that's an inverse sign. And it's inverse sign of u over whatever the a is. In this case, it's 4. And inverse sign of u is x minus 4 over 4. And so I end up there.